Okay, this is the first portion of the hot pass, obviously coming around on the right side, and you simply lay the filler rod above center, and you let gravity work as you pull down on the rod as you sweep over and melt it in place. As before I stated with TIG welding, because of the different polarity, the metal is actually attracted to your tungsten, unlike stick where it pushes away from you. Right there you can see it balled up, and so I pulled the rod out and heated it, and then when the metal was hot I went back in with my filler rod. I think I mentioned that on a piece that I tacked up when I was showing you the proper fit up on the tack there. It's balled up again. Sometimes if you lay your rig back and you actually your tungsten, the heat transfers, instead of in the groove, it transfers more toward the filler rod. You'll melt that filler rod before it has a chance to fuse together with your parent metals. Now these passes, these consecutive passes, are just one right after the next. I had to stop the camera. I had to relocate the camera at times, but when I spliced this together for this take in this film, I just went ahead and ran them right together. This is actually using a dark lens. Later on in some of this study course, I went ahead and bought another lens, which is a 3M. It's a Hormel. It's very expensive, but it does have a quick change application that I was able to use for the TIG welding, so you could see the bevel before I fired up on it. But this lens is just a solid green lens, and there was a lot of darkness before I would fire up, and so I just went and cut that out of there for wasted time, and I went ahead and spliced this together. Now, still coming up the right side, kind of coming up just a little above center. You can tell by the angle it's in the 6G, 45-degree Arkansas bell position. This is the test piece that we had been working on when you saw me use that technique to put the root in. And we're just coming up, walking the cup. You can see the cup rolling back and forth somewhat, sliding. Just really you want to, when it heats up, that material is a ceramic material, and it gets slick when it heats up. Sometimes it's too slick where you slip and you jam your tungsten in your puddle and things like that happen, but it does heat up. It gets very brittle when it's hot. The cups break easy. So here, just coming up again, putting just a good pass of filler, hot pass in there. So when I come back around and I do a filler on this with the TIG process, I've got a good layer in there. I'm not so much worried about it cosmetically and what it looks like. I just want a good fusion in there. I've got my heat probably around 140 to 150, and I'm just laying that, building it up in there, just touching side to side in the bevel, and laying the filler rod in there. Coming to probably another close here. Sometimes you see the rod, I've got pressure on the rod, and what happens is the filler rod is that when you put some pressure on it, it wants to move however wherever the hand is pressuring the rod. That's why the rod jumps. The rod on the right side tends to jump sometimes instead of just laying in there, because the TIG rig is not always, precise with its flow of metal in. I mean, most of the time it is. It's a very controlled process, but even still. Now this pass, I lost a couple of passes on the left side coming up on the hot pass, and this is actually on the top, and I'm fixing to close up the last hot pass I put on with the other pass. Now I'm back down on the bottom again, and this is filler material. You can see that it's fanning out a great deal. It's filling the bevel in almost completely, and that's the design of that. I'm still on the same heat. I'm working that. That discoloration that you see from a dark green to a light green is simply the metal cooling as I go across it with my rig and lay it in there. See, I keep my rod a little high over center. I'm starting to cover up with the cup now on my wrist. But I keep the rod up a little bit above center, and I just let the gravity, look, it's balling up, it wasn't hot. I let it heat up, and watch this, bam, it draws it right in because of that natural attraction and the polarity that we're using with the TIG application. So I continue to come up the side, continuing to just sweep back and forth, trying to keep my tungsten out of the puddle as I layer it back and forth, welding, going back and forth. Got the filler rod just kind of a little above center, coming up on another hot, that's what I said, the continuous film footage there. I actually took a break, had to relocate the camera, and now we're coming up. This is actually some pretty good footage. Good visual on this. You can really see the puddle. You can really see the action of the tungsten sweeping back and forth. And when you dip your tungsten like that, I just did it, it's because of the way that you roll your wrist around, and you have to get a feel for how you roll. That's why I wanted you to watch. Some of this is just me walking the cup, where you're not actually looking at the puddle, but you're watching my wrist as I rotate my wrist and the arm movement, and that's just as important as what you're looking at here. Now, if you dip your tungsten too bad, and especially if you know that you broke a little tungsten off, you want to hit that with a grinder and take that tungsten out of there, because that will show up as a very bright spot in the weld. It's almost like looking at a star in the night. It's brighter than the surrounding area, and that is what's known as tungsten inclusion. Just a little dip here and there is nothing real critical, but if you absolutely break some of that tungsten off, and it happens, sometimes you don't even know, but there is a permissible limit on that on most codes, even high pressure. Still coming around, still walking the cup, just in the groove. Now I haven't switched sizes on the cup, but if you were to step your cup up to say a jumbo, like a number 10 or a number 12, you have less wrist action, and because you cover more ground because the wheel is bigger. It's just like a tire. Bigger tires cover more ground. Same thing principle with the wheel of the tungsten cup and the orifice on your cup. But I haven't changed it. I'm still using the same one. That's why my motions are a lot tighter. The weld pattern is a lot tighter, and it's not that critical. It's not that big of a deal. They do make different size cups, as I instructed before, for certain size pipes, certain size bevels. So this is a whole science, the TIG process, a whole just a total application all of its own. See how easy the metal from the filler rod takes to the parent metal after that surface has been heated up. Still coming up. This is filler on the right side coming up. Oh, stuck it right there a little bit. Doesn't look like I left anything in there though. Tungsten is a little dull on the end. You can see it. I probably haven't changed it in a while. It's good to keep sharp tungsten. Sometimes when you're on the job, you're pressured to really perform, and you can't stop and change your tungsten out all the time, and you'll learn how not to dip your tungsten to keep it sharp and keep a good arc going. But keeping a sharp tungsten makes it a lot easier to move the metal, manipulate the metal back and forth. Really coming up around the right side. You can see the angle is a little different now of where the how the pipe is positioned and where I'm at on the pipe, because it's in that 45 position, but it's really filling in nice. The 1/8 is really spreading out nice, and then after this